Well, welcome. What I have for you right at the moment is an instructor demonstration. And one of the things I wanted to try to do is to convey how important certain techniques are in the microbiology lab. As everyone's working with their kits, some of the facilities that we just can't provide, and some of that's infrastructure in terms of having a full functional lab with gas and all the various other things. But we can improvise best we can. One of the things I wanted to help with today is looking at the Bunsen burner and utilizing aseptic technique around the Bunsen burner. How important it is to try to maintain an aseptic field around a Bunsen burner. But keep in mind that as simple as a Bunsen burner is, there is some optimizations that's really important, and I wanted to go over some of those today. One of which is one of my pet peeves is the striker. This little device, you may be able to see it here. This device is really quite simple. It has a etched piece of steel here, and you can drag a flint over that. Now, the point is that I hear in the lab a lot this going on. I don't know if you can hear that a lot, but I hear that in my sleep. It's I hear folks trying to start. All you have to do is apply pressure towards the flint onto the scoring of that piece of steel that's on there, and what it does, it'll kick sparks, and that's all you need to light up the Bunsen burner. So the striker is simple, cheap as they are. All you have to do is apply pressure in the direction towards the object you're rubbing the flint on, so you can get good friction, and there you go. So allow me to introduce you to the Bunsen burner. Now this one's a real cheap one. It's a simple one. It has places down here for air to get into it, and then a little stopcock at the bottom where I can arrange how much gas is actually getting into the Bunsen burner itself. Now there's lots of different sizes and various things, and my presentation goes over that. But for the hands-on part of this is the Bunsen burner that I'm using. It's relatively low end. So let me go ahead and start to demonstrate a little bit about the Bunsen burner and how we use this for aseptic technique. So let me go ahead and start the flame here without setting my office on fire at home. And you can see a fire is formed, and this is not acceptable. This is one that I see a lot on the internet, and all it means for me is just a simple adjustment where I allow a little bit more air in. As you allow air into the gas flow that's ignited at the top, oxygen of course is real important for combustion, and so I can turn this and you'll start to see a cone within a cone. Now I'm working off a gas can that I use on the grill outside, and if I don't set off the fire alarm in here, I do not recommend you doing this at home. I'm probably breaking all sorts of fire codes. I do have a fire extinguisher handy, so if you start to see a fire, please grab it and put it. Oh, I guess you can't. I guess I'll have to do that. But anyhow, I hope the video will show you that you can see a flame within a flame. And so there's blue area here, and then there's yellow at the top. Let me try to convince you where the hottest part of this flame is. And let me zoom away here for just a second here. Up at the top is yellow, and it takes a while. You can see the wire glowing a little bit. It took a little while. If I go way down at the bottom to get the wire to glow, it takes quite a bit of time. Now if I go in the middle where there's the tip of the cone within a cone, you can see that the wire heats up almost immediately. So the hottest part of the flame is in that region right in there. I hope you can see that. And it's where the wire is glowing from my loop. And so this is just a standard microbiology loop. So this is about the best I can do for adjusting the flame off of a canister. I cut down on the gas a little bit there. So you can see the blue flame, and that's important. This is what we want to work with, and this is really all I have right at the moment to show you. So the idea is the first thing you want to do is adjust. Now in most labs, and it's true at Wake Tech, is that you have a little handle that turns on and off the gas. Well, you want to turn that stopcock all the way on so it's forward facing the tube that's positioned into it, the hose. And then you want to adjust your Bunsen burner at the bottom, the stopcock, for the gas flow and the amount of air. So once it's set, then no matter what the setting could have been on the handle for delivering the gas, you leave that wide open and you'll have a reproducible already set up flame for you to use every time. So this is from what I have to work with. This is pretty good. This does the job. Okay, so now what I wanted to do is talk a little bit about the aseptic field. Now there's certain slides that I'm going to go over in the regular presentation that goes into that. Let me see if I can find that really quick here. There's the burner, and this is what we're talking about. The air hole, this is one of them that I can adjust at the bottom, and then of course depending on the type of the gas burner. But what's happening now is you're getting air that's being heated, and it's going up and it's going down, and it's going up and it's going down, and we call that the convection current. So on the table I've written out that there's about 4 centimeters from here, from the center part of this, 4 centimeters, or if you want to do it in inches, it's about 11 inches diagonal in both directions, is sort of the area that's influenced and is considered aseptic, and this is the area in which you want to work. It's real important that you try to identify an area that you want to work, and I define that as this sort of area that's around, and you can feel the heat. And again, though, it's convecting up, and then the air starts to cool and it starts to fall down, so you get this convection. And that's pretty amazing for something as simple as this Bunsen burner. So this is the sterile field, and it covers about 11 inches, or if you want, this is about 5.5 inches on either way. I guess you can say it that way, 5 inches or so, or 4 centimeters or 8 centimeters total in either direction, and that gives you a good feel for that sterile. So that's the area that you want to try to work in. So if you have media or plates, here is a blood auger plate, and typically, by the way, you store or have these around your bench where the tops are down. This is the top part that comes off, and the media is on the bottom. And so excuse the French, but bottoms up. And so with that, so I can grab the bottom, move and open the plate and close it. So it's like a door. I open and close the door, but I'm going to do that within the aseptic area as best I can. And what that does, no, it's not perfect, but what it does, it minimizes the chances of getting a contamination, and that's what we're here for. And so we want to inoculate or do whatever we want to do. So we've covered several things, but I just want to make sure that you've gotten the idea behind the flame has to be set so we have at least 2 different colors of blue. And we see the very tip of the inner flame, the cone, is the hottest part of the flame, and the top yellow and the down lighter blue at the bottom is not anywhere near as hot as that. So if you have a loop that's hot, this is inoculation loop, which I'll go over in a little bit, but I can lean that on the base, the metal base here, because if it's hot, then you just want to be careful not to lean it on a hose, or you might be using a fire extinguisher, and we don't want to be doing that. So that's pretty much 8 centimeters, the full distance, and the flame is properly adjusted in review to create this convection current, and so that we can work with loops and bottles and igniting alcohol on culture spreaders and all sorts of things, and we'll talk about those. But it's based on the fact that hot air rises and forms a convection. Everyone knows that, and we adjust that flame to get the cone within the cone by the vent. I even have a drawing that matches the type of Bunsen burner. How amazing is that? Even during a lockdown or in a home, or it's just amazing what Wake Tech can do when really needed to. But anyhow, so there's the gas flow adjustment that adjusts the how much gas actually gets into the Bunsen burner and the airflow. And not everybody can have these wonderful Bunsen burners like I have. There are some different types. It's closer to what I have. The second one over here is you don't see an adjustment, so you have to adjust the gas by the stopcock to adjust the flow of the gas to it, or it has a stopcock at the end of it, so you have to kind of look at your device. There's one there, and sometimes they don't have them depending on what you want to use. And then the air is managed here, so the amount of air that you allow into the system, there is the right mixture. Now, if your flame sounds like a 747 taking off, most likely you have too much air. You need to cut this down by spinning this around, so the air there's less airflow going in. So there's a right air and gas mixture that we want to achieve to get the cone within the cone, and that's really what we wanted to try to achieve. Now, we don't have to always use a Bunsen burner. We can use an incinerator. A lot of times you'll see these in hoods, and I'm going to talk about what a laminar flow hood is. But all this device does is allows you to heat the loop, but to heat the loop in a different way, and so it's incinerated in the inside. You can see the red hot. It's sort of like if you've ever seen those things that they blow for gas blowing to make glass really, really hot, so you can mold it to form things. But I don't want to see flames that look like the yellow little wimpy flame, because that is a disaster. This is closer to more what you want. That's a fancy whatever that Bunsen burner is. So you might see a question on a lab practical choosing which of these might be the best for using the aseptic field in your loop and that sort of thing. So you got some to choose from, and I'm going to go ahead and tell you, because I know you already know the answer. That's the proper one, because you see the flame within the flame, and we're good with that. And so when we heat up for our loop, is we want to put first of all, make sure the flame's right, but we don't want to go at the top. We want to go in the center of the flame, which I already identified as the ideal place, is right in the center. You can see it heating up, so I go down and warm up. Now, this is already metal. It's already formed, so you don't need to reforge the steel or anything. You just need to kind of go through and go downward, and eventually you can turn it around, and that's about it. It's ready. It's sterile, and it's ready for use. And so you can go and pick up your cultures or whatever you want to do with that. And then once you finish with your culture, you can go back to your flame and get your loop sterile, and you can park it. And that's all I wanted to show in this segment with the hands-on, is the proper use of a Bunsen burner. And our goal is aseptic field, and managing that aseptic field so we can work with plates and various other types of manipulations we can actually do within that field. Look at this, tube to a tube transfer. We can do tube to tube transfers. It's easy within that aseptic field, and I will show you that later on. So doing a tube to tube. So typically we go from plate to tube or tube to tube. So those are important skills that I want you to have. But we'll talk about that at a later date. So as far as the technique video portion, this is the aseptic part, and I hope you enjoy that, and more to come.